For the circuit shown in figure, E equal to 50 volt, R1 equal to 10 ohm, R2 equal to 20 ohm, R3 equal to 30 ohm, and inductance L equal to 2 millihenry. Find the current through R1 and R2. And this is the circuit. First case, immediately after switch S is closed, that is T equal to 0. When at T equal to 0, when switch S is closed, then the resistance through resistance across the inductors is infinite, that is R equal to infinite. So current across the resistance R3 is 0, that is current through the resistance R3 is 0. So the current will pass through R1 and R2. So the current through R1 equal to current through R2, and the total resistance in this case is R1 plus R2, that is say R equal to, that is here R1 is 10 and R2 is 20, so 30 ohm. So I equal to 50 by 30, that is 5 by 3. So in this case, current through R1 and R2 is 5 by 3. In the second case, a long time after S is closed, that is T equal to infinite, then the resistance offered by the inductor after a long time is R equal to 0. So that is L is here is short circuited. So here R2 and R3, so the equivalent circuit in this case becomes, that is close S and R3, and L is short circuited. So this is R3, this is R1, R2. So R2 and R3 is parallel, that is equivalent resistance is R2 R3 by R2 plus R3. Here R2 is 20 and R3 is 30, and this is 20 plus 30, so R prime is equal to 600 by 50. So this is basically 12 ohm, and total resistance R is R1 plus R prime. Here R1 is 10 plus 12, that is 22. So the net current I is I equal to, voltage is 50 voltage and resistance is 22, so this is 50 by 22 ampere. Now the current through the branch R2 is, and this is the current through R1, and the current through resistance, current through the resistance R2 is basically I into R3 by R2 plus R3. Here I is total current, that is 50 by 22, and R3 is 30, R2 20 plus 30, that is 30 by 22, that is 50 and 50 cancel, so 15 by 11. This is the current through the resistance R2. Now in third case, immediately after S is reopened, that is when when the switch now opened, then when it is immediately reopened, then the current through the resistance R1, that is I, is equal to 0, and current through the resistance R2 is equal to the steady state current through the resistance R3. Steady state current means at a infinite time we see that current through the resistance R2 is 15 by 11 and current through the resistance R3, that is total current 50 by 22 minus 15 by 11, so this is basically 50 22 minus 30, that is 20 by 22. So this is the current through the resistance when t equal to infinity. And now when we reopen the after that, when we reopen the switch S, then the current through resistance R2 is equal to the steady state current is R3, so this is basically 20 by 22, this is 10 by 11 ampere. And after a long, and in fourth case, a long time after S is reopened, that is then the total current through all the resistance becomes 0.